Okay, let's start our exploration. In this exploration, as we mentioned earlier, we're going to use our electrostatic model to try to explain and get some deep understanding of two methods of charging an object, one called conduction and the other called induction. And we'll start, this movie is on conduction, and it's the process of charging an object by direct contact with another already charged object. Well, here's our electroscope from our last discussion. Remember, the electroscope is made up of a continuous conducting material, and there's a pivot here and a lever arm that can twist away from the center core if there's a reason for it to do. And then this is all insulated from its environment, so it's isolated from, this whole system here is isolated from its environment. So that's our electroscope. What I'm going to do in this first part of the exploration, I'm going to bring a rubber rod that has been rubbed with fur. So here's our rubber rod, it's rubbed with fur. You remember from your charge model what that means. And here's our electroscope, and we observe that the lever arm has been, for some reason, our observation is it has been pushed away from the center core, from the top and the bottom, and is now, while the rubber rod is there, is at this angle. We're trying to understand why that is happening. I'd like to give you a chance to, keeping in mind our charge model, visualize what is happening to both the positives and the negative charges in the rubber rod and the electroscope. The rubber rod, remember, is a insulator. The electroscope is made up of all conducting materials, and we'd like you to make a conjecture. So take a moment to write down or make a sketch of what is happening to the mobile negative charges during this part of the conduction process. And please pause the movie for a moment while you make the prediction. We know very much so that students learn and own materials much more deeply when they actually take intellectual risks, they make predictions, they put on the table their belief system before they are told or read an explanation. So take a moment. It really will be good for you to make your conjecture, and then start the movie again once you've done that. I'll be back with you in a moment. Okay, hopefully you've made some conjectures, and remember this. There's this very highly negatively charged rubber rod, and a way to visualize it is there's a pretzel here that's covered in chocolate that's been dipped in sprinkles, and these sprinkles sort of represent all these extra negative charges that are residing on this rubber rod with a fixed number of positive charges that don't move. The electroscope also has a fixed number of positive charges, and they don't move, but the negative charges here are mobile. So as the rubber rod with its highly negative charge gets close to the top, the mobile electrons here, because like charges repel, that's part of our model, are actually being forced down this center core, and because there's a conducting path into here, and so now we have a center core that is slightly negative, being pushed down from here, and a lever arm slightly negative, and so it repels and is actually pushed out from the center core. Now, the total number of negative charges and positive charges in here is still neutral. This is still the same number, but they've been redistributed due to this presence of this negative charge up here. So this is still a neutral object, but a redistribution. Sometimes we say the object has been slightly polarized, the top part being slightly positive and this bottom part negative. Is that what you conjectured? All right, so now what I'm going to do, I took the rubber rod, this rubber rod rubbed with fur, this highly negatively charged rubber rod, and actually touching it and slightly rubbing it against the top of the electroscope, the conducting surface of the top of the electroscope, and we see that the lever arm is even pushed further out. So we would like you again to conjecture, to think about, visualize what you think is happening to the electrons in both the rubber rod and the electroscope during the process. So please take a moment to make the conjecture, to either draw a sketch or write down your thinking on what is actually going on with the electrons and the positive charges, the negative charges within this two object system. So why don't you pause the movie for a moment, and at least think through, state in your mind. If you don't write down, we'd prefer you actually draw a sketch or write down. But take a moment, please pause the movie and make a prediction of what you think is happening. All right, welcome back. So what is going on now is the negative charges that are, you remember the visualization I gave you of the pretzel with the sprinkles? These sprinkles here are actually now rubbed onto, the negative charges actually rubbed onto the conductor. Remember, it was polarized, so the top of the conductor was slightly positive and the bottom slightly negative. And so these negative charges that are right on the surface of the rubber rod are now actually transferred onto the conductor and are continually pushed down. So the core of the electroscope and the lever arm are even more highly negative, as these negative charges are very close to the top and actually transferred into the electroscope at this part of the process. Well, here's the electroscope after I removed the rubber rod. I hope you can observe that the lever arm now is somewhat more repelled from the center core than in the very first one when the rubber rod was way up here, but is not quite as far repelled. The angle is not quite as large as it was when I actually had the rubber rod touching here. There is nothing now causing any unbalance or non-uniform distribution of the charge in here. It is uniformly charged, but it actually now has an excess of negative charges. So whatever number, 10 billion, 10 negative charges, whatever that stands for, that has transferred here are now nicely uniformly distributed onto the electroscope. And so it's permanently has a net permanent negative charge. It's not permanent, we can remove it, but right now it has a net negative charge, and so the lever arm is pushed out from the center core because like charges repel, and this now has an unbalanced negative charge. What I'd like you to think about is, what do you think would happen to the lever arm on the electroscope if I now brought a freshly rubbed glass rod near the top of the electroscope? I'm not going to let it touch, but I'm going to bring a freshly rubbed glass rod with silk near the top of the electroscope. What do you think would happen to the lever arm if I did that? And secondly, I'm then going to remove that glass rod and bring a freshly rubbed rubber rod and bring it near the top of the electroscope. And again, I'd like you to conjecture on what do you think would happen to the lever arm under those two situations. So again, it is our firm belief that if you actually make these predictions, make these conjectures, you will understand and learn and be able to actually be self-testing on how well you've learned the material that we're presenting. So take a moment and make a conjecture. What do you think would happen if we brought a glass rod charged positively near the top of the electroscope? And then secondly, after we removed that glass rod, we now brought a rubber rod, a freshly rubbed rubber rod, charged negatively near the top of the electroscope. What do you think you'd see happening to the lever arm under those two circumstances? So again, please pause the movie for a second, reflect on these two queries, and then restart the movie after reflecting on these two queries. See you in a moment. Okay, well, here's the glass rod brought near the top. The glass rod has a deficit of negative charges, so there's some missing negative charges from here. And what happens is some of the negative charges in this electroscope are actually brought back up or tracted up more towards the top of the electroscope. So we're bringing some of the excess negative charges up from the bottom. So we're causing the distribution within here of the excess negative charges no longer to be uniform. It's still exactly the same number of negative charges here as it is here in this top picture, but we've redistributed them because of this positive source here, some of the negative charge moved up, so the repulsion down here is slightly less, and the lever arm is not the angle is smaller than it was in the original case. Now let's look at the case with the rubber rod. I hope you saw this, predicted this as well. With the freshly rubbed rubber rod near the negative charges that were uniformly distributed up here, some of those negative charges that were out here are forced by like charges repelling again further down into the electroscope, causing the lever arm to create a larger angle, a larger repulsive force here, and so the lever arm is pushed out much further. But again, I want you to remember that the number of negative charges, extra negative charges here, and in this top picture are all identical. It's just how they're distributed because of the influence of the positive rod or the negative rod or no rod. There's no transferring a charge, it's just the redistribution. I hope that makes sense to you. So we just went through the process of conduction. In that case, a charged object, in our case was a rubber rod, a charged object was touched to an uncharged object, and the uncharged object acquired the same charge as the charging object. That's what happens during the process of conduction. The charging object and the charged object obtain the same charge. I just want to remind you a little bit about what happened with our case. We had the rubber rod. It was rubbed with fur, so it had a lot of negative charges on it. And when the rubber rod touched the conductor, some of those locally excess negative charges on the rubber rod actually were transferred into the conductor. In the conductor, the electrons are mobile, so they could flow, and they redistributed themselves. On the rubber rod, which is an insulator, those missing negative charges, it's sort of analogous to if you went to a haircut and electric razor was used, you get a little buzz cut in one spot. And so the rubber rod now is basically still covered with a lot of electrons except in that one spot. And because it's an insulator, the electrons from the surrounding areas don't easily flow back into that spot. But regardless, when you charge by conduction, the object being charged acquires the same charge as the charging object. And so here, in our case, we have a negatively charged electroscope charged by a negative rubber rod. A final slide of this movie, we look at neutralizing or grounding, sometimes it's called, the negatively charged electroscope. So the electroscope had an abundance of negatively charged. Negative charges repel, so if they have a pathway to get away from each other, they will do that. By putting my finger on the top of the electroscope, I actually make a pathway for the excess electrons that were on the electroscope to escape out through my hand into the ground, and we call this grounding. And so the electroscope is now neutral again. And so there it is, an uncharged electroscope. And so that concludes our exploration on conduction. And when you're ready, please watch the movie on induction. I hope you enjoyed this and feel you understand the material, and we'll see you in a few moments. Bye-bye.